Hey everybody, welcome back to the 109th episode of Taps of Patience. I'm AJ with Audacity Micro, here with Harrison at Precision Ingenuity. How you doing, Harrison?
I am loopy. I have been going 100 miles an hour since November. So I'm ready to slow down a little.
Yeah, I don't blame you for that. Yeah, I've been running like crazy for the last 4 weeks or so. And just like today was kind of my first day of not being running around crazy.
Mm-hmm. Yeah, I've picked up like 3 or 4 new customers, kind of, and so it's just been crazy trying to keep up with it all. And I just lost audio again.
Uh-oh. Well, I'll talk while Harrison figures that out. I was working on that super big job that I took, the one that's like 2015 pieces, and the first 600 of that were due. I shipped the last of them like 2 or 3 days. No, was that yesterday? I may have shipped the last of them yesterday. Yeah, that was yesterday. I shipped the last of them yesterday, and they were very late by the time I shipped them. Can you hear me now, Harrison?
I can hear you now. Like my whole web browser froze up.
Oh, interesting.
So
I was just
my
talking about the
headphones.
big job. So the finally the last bit of those shipped yesterday.
Ooh. How many did you ship in total?
615.
615. Okay, so that leaves you a little under 1,400 left to go.
Yes. It's exactly 1,400, I believe. 800. I have a batch of 800 and a batch of 600 left.
Yeah, but you did 615.
Yes.
That's what I was saying. Technically,
did I say 600? I probably rounded.
Yeah.
But I have 800 due in like 8 weeks or something, 6 weeks, mid-April-ish, which I'm going to start working on slowly here in the background so this doesn't happen again. But man, that job did not go smoothly. Are you still able to hear me? Uh-oh.
Oh, my headphones
Dude,
again.
we record for the first time in like
I'm going to try using
4
my other
weeks
headphones
we have technical difficulties
these things are just not working.
I'm going to pause. I just accidentally unpaused, so I guess we're back and running again.
Oh, okay.
That job went very not smoothly. And I've kind of been thinking about some of the reasons why. We can talk about it a bit more. I think the root cause the root cause came down to me getting started super late because I didn't have time because of other jobs that went long. But the other root cause was work holding. And I went through a couple iterations of the work holding, and maybe even more specifically, there was a mismatch between the work holding and the size of the tools that I was trying to use.
Mm-hmm.
Because I was trying to get cycle time down as much as possible. So I was trying to use a 1/2-inch end mill and, feeding as fast as I could, cutting as aggressively as I could. And I think the work holding that I had was not quite adequate for that.
So have you tried running with a 3/8 inch end mill to see if you can get even faster? Because sometimes, ironically, you can go down a size and speed up your MRR depending on where your machine falls.
Yes. So what ended up happening is I ended up breaking all of my 1/2-inch end mills. And so I started switching to different tools. And what I ended up landing on was a 8mm tool. Seemed to be the best balance between like not having stupid long stickouts for its size, but also being small enough that it wasn't putting too much force into my work holding.
Mm-hmm.
And so I'll probably go with that on this next batch 8mm tools. 3/4 works pretty well, or excuse me, 3/8 works pretty well as well.
Mm-hmm.
But it's just a little bit bigger than the 8mm.
Yep.
The other thing I think I need to do. Okay, wait, I should take a step back and describe the whole process for everybody who's not aware. The piece starts off as a block. It's approximately a 2-inch cube. It's a little bit less than that in reality, but it's approximately a 2-inch cube of 1018 steel. It is a 3-op part. The first op I originally was doing in my 6-inch vise with serrated jaws until I broke my 6-inch vise. And then I switched to doing all 3 ops in those import vices on a row of pallets. And the first one I was still doing in like the baby version of the serrated jaws. And then I had the second and third op that I was doing in soft jaws. And I never, well, with one exception, which we'll get to in a second, I never had issues with work holding for the first op. That was pretty consistent the whole time. But the second and third op, the problem I was running into is if you look at the piece, it kind of looks like the Z-shaped Tetris piece, the one that's like it goes over and then down and then over.
Mm-hmm.
And when you are, so I could only hold it by like the bottom of the Z-shaped piece, and then you still have to machine on the part, like the opposite side that is unsupported and not being directly clamped in the vise. So it's cantilevered. I had to machine on a cantilevered thingy.
And you couldn't if it was a Z shape, you couldn't grab onto it and have that part that's hanging out offset to in a set of soft jaws hanging out, where you could support everything except for that overhang and then machine it.
No, because so it's that Tetris. If you look at it from the front, it's that Tetris shape. But if you look at it from the side, it's also an L shape. Like there's a funky post hanging out and sticking up.
Mm-hmm.
So it's kind of overhung in two different ways. I tried many different combinations, at least in CAD, of how to do the soft jaws better. And I just couldn't really get to anything that worked better.
Gotcha.
But anyway, so I had this kind of overhang thing. I tried a bunch of different ways to make it not cantilevered and just couldn't really come up with anything that worked. But I think that was causing some like vibrations and some extra forces that were causing vibrations in my soft jaws, which were slowly breaking down my soft jaws.
Okay.
And because of that, they would, after 30, maybe 40 parts, the soft jaws would get like distorted enough that parts would eventually, like they would get a taper on them. So the bottom was smaller than the top. And that would either lead to accuracy issues or cause the part to leave. Normally it just would kind of tip where the cantilevered part would go down and then it would break the tool. Pretty reliably, it would break the tool. So I eventually figured out that like when I made the soft jaws, I would put 3 shims in there and then 3 16th inch shims. And I would run a couple parts and then I would put 2 shims back in, recut my soft jaws and run more parts and so on. And whenever I would see wear, I would just make the soft jaws a little bit smaller.
Now,
and I was getting like 100 parts out of a pair. Well, I was getting like 200 parts out of a pair of soft jaws.
And this is in the flux vise?
That was in the Chinese vices.
Oh, Chinese vices. Okay. Did you think about making some hard jaws? Machining some hard jaws?
So that is what I should have done. And that's what I'm going to do this next time is I'm going to go to steel jaws.
Okay.
I still haven't really thought of a better way of doing the work holding. I could probably get away with a blunt nose pit bull for the second operation, which might give me more holding force.
I still need to look at this part and give you my 2 cents on it.
Have I not shown it to you yet?
You haven't shown it to me yet.
Oh. I can send you the file link right now. But anyway, so that kept breaking my tools. And why can I not share this file? That is so bizarre. Because it thinks I'm offline. So I kept breaking tools, and then that ended up with me. That kind of pushed me in the cycle where I would break the tools that I was using. And so then I would have to change to some other tool that I have laying around, which would cause me to need to reprogram it or at least tweak the program. And, sometimes I'd make mistakes. Sometimes I'd have to dial in speeds and feeds. It took me a while to figure out what exactly was going on with my soft jaws. And so I just broke like a ton of tools. I scrapped a ton of parts. And it just like, I think because I had several variables that were causing issues, because the other issue is that 6-inch vise I had was slowly dying. And I used the same soft jaw design on that at one point as well. And I didn't understand that the vise was dying, which was also like throwing in a variable to my like as I was trying to figure things out, because the
How did it die? How did the vice die? Just to get an idea of it.
the there was a crack on the fixed jaw side. Now
Okay.
that vise already had some other issues due to some cast iron breaking, like underneath the mating interface, and I think that caused me to go, "Oh, I just need to tighten it more." And so then I over tightened it, and I think it broke the. Well, I know that it broke the fixed jaw. So I did buy a new Haas 6-inch vise, but I have not put it on my table yet. What I did instead was I took my other Aroa fixture off of the office mill and stuck it on the table and just used that. But anyway, I broke a lot of tools and I scrapped a lot of parts, like a stupid amount of parts.
Oh man, that's not
I
fun.
I scrapped over a bar's worth of parts.
Ooh,
Yeah, it was bad.
that is really bad.
It is really bad. That's why it took me so long. Well,
Oh
it's one of the
man.
reasons why it took me so long. It was both a cause and a symptom because I
Okay,
wasted so much time making parts that I couldn't ship, and also
so
because I was just having all kinds of problems.
I'm gonna go back on some things that I've said in the past right now, and I'm gonna say before you make something fast, you have to make it reliable. And if you were focusing on speed the whole time, that might have been the wrong approach. And so, what I do a lot here recently is I will try to make something reliable, and then I will look at a reliable process and try to speed up that reliable process as much as possible. And so, I still try to go as fast as I can, but I will not sacrifice quality or reliability in that pursuit.
Yes, which I totally agree with. I definitely got caught up with like I knew I was running so far behind. It was like, okay, I cannot waste time
Mm-hmm.
anywhere. And that definitely came back to bite me because as slow,
Mm-hmm.
smooth is fast.
Mm-hmm.
And I did none of that.
And
I was
always
slow
feel
and not smooth.
always feel like you could still reach out. Like if you need a second set of eyes, I'm always here to help out best I can.
I this is a thing I know that I do, and I should probably get better at. When I have a project like this where I'm struggling, like I just want to focus on the project
Mm-hmm.
and do nothing else, think of nothing else outside of it. Just like, you know, I was gonna say bury my head in the sand. It's not quite that, but like I just focus on it. I have
Mm-hmm.
more than 50 Instagram messages right now waiting for me because I've just been like not doing any social media. I haven't made
Mm-hmm.
any YouTube videos, nothing. Like I've just been focused on this. And it always felt like I was almost done. It was
Mm-hmm.
like, okay, this one last tweak will fix everything. This one last tweak will fix everything.
Mm-hmm.
And there's always just one more stupid little thing.
Mm-hmm.
And like I think I literally told my wife 5 days in a row that it'll be done tomorrow.
Mm-hmm.
And it just kept not being done tomorrow.
So, anyways, I can I could an ear or someone that can maybe help you in those situations for future reference.
Yes, I should have sent you those files. I do regret not asking for help sooner.
So
Uh,
that's all right. I mean, that happened to me as well over this little break. I had some new customers, and they came to me with some projects. And to be fair, when I initially talked to them, the due date that they told me verbally in person did not line up with the POs that we eventually got.
mm-hmm.
They ended up being like a month quicker than what we had talked about, and ended up with twice the parts that I was thinking it was going to be. And so we got those parts, and I way underbid them, and two, I way underestimated them because they had a lot of geometric tolerancing
Okay.
things that, like, on their own, any one of those tolerances wasn't that bad, but the stack up
Yeah.
between how they did things and the way there were a lot of them were out of 1018 cold rolled, and when I
Mm-hmm.
started removing the 1018, I would machine one side and it would be perfect. Then I'd flip it over and machine the other side, and it would warp and twist and throw things out of spec.
Yeah.
And so those parts ended up taking a whole lot longer than planned. And so we ended up having to go back to the customer and tell them that if they have anyone else that can make some of these parts, there's no way we're going to hit the deadline. And I knew they were under the gun for these parts anyways. And so they ended up taking about half of them back. And I technically have 2 more parts that I need to finish up before tomorrow. And Friday is the hard deadline for when they need them all by. So
Before the end of the day tomorrow, right?
yeah.
Okay.
And so, but the parts I've been making have been gorgeous, and I've been super happy. It's really upping my game again. It's that bending and stretching and pulling and pushing you right to the limit. That when you get
Yeah.
to the other side, you're just that much better of a machinist. And so, in all of this, I haven't even really talked about. We've started. We got our new UMC, and so I've been putting it through its paces.
Woohoo.
And I think since we've gotten the machine commissioned, we've been averaging an 80% spindle uptime on the
Holy
UMC.
cow. During the day, not
Yeah,
including
like
nights.
when it's turned on.
Okay.
So 80% spindle utilization while it's turned on, and we've already put. It's 4 weeks old, 4 weeks old, and I was trying to remember. I thought I took a photo of it, but I think we've put in 3 to 4 weeks. We have put 130 hours on it, something like that, in like 3 weeks.
Nice.
So pretty cool. Mainly to say that like we've just been using it nonstop, and basically it's running production. It's running a production job if we're not using it, and then I'll stop the production job and switch over and run individual parts if I need it, and then it'll go right
Nice.
back to running production.
That is definitely the way.
So, and we set it up with Lang plates and fixtures, and it is just I love it. I have had to check MRZP a couple times on it. Whenever they installed the machine, it took them 2 days to get the machine leveled,
Uh-huh.
um, and they kept fighting it. And there was a weird twist in the casting. And so as the machine sits and kind of settles into place, especially in the beginning, I'm having to watch MRZP and kind of check it like once a week or so, or every few days, just to make sure, because it's definitely, as it's kind of warming, cooling, getting used, it's kind of moving on me a little bit here and there. So, which makes sense. Ironically, my VF is a lot more stable in MRZP right now, just
Hmm.
because like it's been sitting there and going for about a year, and I've got it dialed and I haven't really been pushing it, and so it's holding tolerance, or it's holding position better than the UMC right now, but that's just the UMC kind of getting used to its new home.
I just did some quick math, and my Tormach averaged 9 hours a day for the last 21 days
Mm-hmm.
of actually making parts.
That's a lot.
And especially when you consider that I've been teaching for 2 weeks of that, which with drive time takes me about 6 hours a day.
Oh man.
So yeah, I've been running that thing a lot. Chip management was another thing that we got to learn about on this project. That's not something I've had to deal with before.
Oh yeah, are you going to get what's it called?
The conveyor.
Yeah.
I will definitely at some point here, probably this year. I I very much need one. It was rather annoying scooping the chips out of the back of the machine constantly. Most of the
Mhm.
time, it doesn't really matter for me, but it's such a luxury to have it anyway.
Oh yeah.
I made about 1,600 pounds of chips over these last 3 weeks.
Really?
Yeah,
Wow. That's a lot
I
of
ran a
chips.
lot of parts. Yep, and these parts have a fairly high material removal. Probably, I don't know, 65%, 70%, somewhere in there.
Yeah. The the production job I'm running has a 93% material
Oh
removal.
gosh.
Like, and that's by weight. So I weighed one, and then I weighed a finished one, and
I should do that
it was
to get the exact
93%.
number, but
So it was pretty
what
wild.
material is that?
Aluminum, just 60
Okay.
61. So it's, I mean, this year we're averaging with this production job, we've been averaging a 255-gallon tote of aluminum chips once every week and a half. So it's per day. Um, we're probably dumping like 80 gallons of chips or so, something like that.
My
So,
plan tomorrow is to finish emptying out the machine. Right now, the machine, because I was on that last final push, the machine is just full of chips. So I need to get those out of there and empty the chip trays and gather all of my various totes
mm-hmm.
and get those to the scrap place. Today was largely a day off for me.
Oh, that's
I
nice.
theoretically was still supposed to teach today. I ended up I drove there. It's like an hour and 15 minutes to get
Mm-hmm.
there and about an hour to get back. But I drove an hour and 15 minutes there and nobody was there. And I waited half an hour and sent the guy a text. And then half an hour later I got an answer that was like, "Oh yeah, we're not coming today." And
Nice.
so then I turned around and drove home. But I wish I'd known that in advance because I would have loved to just,
Oh,
hang
yeah.
out with my family instead of wasting
3
a little
hours.
over 2 hours driving. Yeah.
Oh, yeah.
Plus an hour of sitting around.
Yeah. No, thank you. That's
But,
annoying. How do you like teaching?
oh, I'm really enjoying it. It's great. At bare minimum, it's a nice break from like, running parts.
Mm-hmm.
But I do enjoy the teaching. Lately, we've been kind of in this phase where they have a project and they just kind of work on their project throughout the class. Normally, I start off with like half an hour of lecture,
Mm-hmm.
and then of quote unquote lecture, and then they'll work on their parts for like 3.5 hours after that. And so I've been just like playing on the machines that they're not using. So we have there's
Yeah.
5 people in the class. We have in the room that we're in, we have 4 bridge ports, 4 grinders, and 3 functional lathes. We have 1 lathe that doesn't work.
What about
So,
CNC? Or is there any
oh,
CNC?
so right now we're doing manual stuff.
Oh, okay.
In the CNC room, we have, I believe, 6 lathes, 4 VF2s, and 3 mini mills.
Oh, yeah.
So we got a ton of CNC equipment. This class doesn't really get deep on that. And I actually need to figure out how I'm going to teach it. Because last time I only had 2 students. And so like we just ran 1 mill. This time I would have to like either have 5 people standing around operating 1 mill, or
Mm-hmm.
I'd have to try to supervise multiple mills at the same time and have them not crash them.
Yeah.
So I'll need to figure out how to run that safely, but maybe do
Yeah.
2 mills, 2 people and 3 people.
Yeah.
I also found we have the control, like the Haas control simulators.
Mm-hmm.
So we can do some more classroom stuff on those. But they're not like programming. They're running known programs. They're just
Mm-hmm.
setting tools. They're setting offsets and running programs that are given to them.
Gotcha.
So like operator stuff.
Then I feel like you could safely, like if you know the program's safe and you know they set it up safely,
Well, that's the
then
question. Is it set up safe?
well, you could. I mean, if you could cycle through your tools and make sure they've been touched off and make sure your origin's in the correct spot and your parts in the correct spot, then you don't have to worry about the program after that.
Yeah. Yes. True.
And so, versus whenever I was teaching, it wasn't just are the tools set up and the origin set up. It's is their program good, because everyone was writing their own program, and
Yep.
so that was a whole different element of needing to watch over things. Because even when you're simulating things, sometimes I would miss things that the students did. For example, one of the students was running a part, and it had 3 pockets that needed to be adapted away.
Mm-hmm.
And so I watched the simulation and I watched it go through all 3 pockets, but I didn't pay that close attention because the middle pocket, they had apparently selected a pre-drill hole location, and so it thought it could plunge into the stock. And so it did the first pocket, and we're just sitting there talking with the students, and thankfully I had my hand on the feed hold because I was trying to explain something to them. I was something about the rapids, like this is what the rapids look like, and so I did like 100%, 25%, 50%, like in between them running like while the program was running, just showing them the different speeds that the machine was capable of, and why we were running it slower. And then like in the middle of that, it came over, and I was like watching it come down, and it started to plunge, and I stopped it like half plunge, and
Like
you
the
know,
tool
like
halfway in the material.
yeah, so like it didn't make it all the way to the bottom of the deal, but oh, it startled everyone, including myself, and I was like, okay, let's go look at the simulation because I obviously missed something that
Yeah.
you know. So, and that was what it was. There was no helix on that one. So,
I did have a kind of crash on the Tormach.
what's a kind of crash?
So the program took a couple steps down in an adaptive,
Mm-hmm.
and the tool was not long enough to well, the tool broke on the first step down on the adaptive, and then it wasn't long enough to like it tried to go the I'm having a hard time describing this. Tool broke, the machine thought material was gone, material was not gone, and it did a X move into
Mm-hmm.
the material with the collet nut and welded the collet nut into the material.
Oh, nice.
So that was fun.
Mm-hmm.
I was gonna leave it there because I had to get it off. I had to press the drawbar button and jog up in Z.
Mm-hmm.
I guess I could have removed the material from the vise as well too. And I was gonna leave it there with it all welded together, but I needed the tool holder, so I had to
Mm-hmm.
unscrew the tool holder and put on a new collet nut. But I was gonna leave that as a trophy. Everything
Nice.
seems fine though.
That's
Um,
good.
it basically would be like if it took a really heavy cut with an end mill.
Mm.
So it's fine. The spindle stalled. The axis didn't give up,
Oh,
which sounds about right for the machine.
so does it not have a like if anything stalls out, it automatically e-stops?
No, it will. The axis just had enough force to keep going, and I
Oh,
ran out of horsepower. If I had more
gotcha.
horsepower, that thing would have welded all the way through. Straight friction
Gotcha.
stir welding.
Gotcha. Well, yeah, I realize that, but like the spindle stalling out, it stopped at that point. Like
Yes.
it okay, because I remember on the 1100, I had something like that where either the axis stalled or the spindle stalled, and I want to say it was the spindle stalled out, and the axis kept going, and it didn't e-stop the machine.
Yes. The 1100s, they would notice an axis stall, but they could not tell a spindle stall.
Which I thought was weird because they had the encoder on it. I
They
was
do
like,
have an encoder. That's
why
true.
weren't you reading the encoder the whole time? Like as long as like or like if the RPM dipped too low, it wouldn't stall, it wouldn't error out. And I was like, why aren't you reading the, you know, desired speed to current speed? And if it goes, 20% out of range, error out. So um I guess that's a question for
Norman?
yeah, Norman.
Yeah.
Norman, what's going on here? Why aren't you
I
reading
will
that?
say, before I broke my 6-inch vise, I was pushing that thing hard. It was
Yeah.
taking some really aggressive cuts in the steel, and like they were kind of set up. Like you can go up to 300% of spindle load,
Hmm.
and I was at like I had it the speeds and feeds tuned to be at like 296
Mm.
for that like first initial roughing adaptive.
Wow.
And in fact, I had to go dial that down because when my tool got dull,
Yeah.
it would air out on me.
Hmm.
It's like, okay, I pushed you a little bit too hard.
Speaking of like measuring things, I did put a amp meter on with all four machines running,
Okay.
and
On your main feed?
on my main line, and with three phase and four machines running. Now they weren't running like really heavy workloads, but I was averaging around 50 to 70 amps average, and it would peak up to about 150, 175 with
You
the
have
four machine,
200 amps?
and I have 200 amps.
So you can get another machine or two in there.
So depending on the size,
Yeah.
and that was with four machines and the air compressor, but no heat and air, no AC. So once you add
Okay.
AC in there, that'll add a little bit.
So you
Uh,
need to upgrade your feed if you're going to
yeah, if we're gonna
grow
get
any.
another machine, we need to go up to 400 amps. But I've been averaging, well, provided I shouldn't say averaging, but like I've been able to get up to 750 of these parts done per week of my production
Nice.
job. So between two machines.
Are these the magwells or a
Mm-hmm.
different part? Okay.
Magwells.
Do
So
we
like,
publicly say that on the podcast? Is
yeah, I
that
can say that. I mean,
okay?
I brought the parts to IMTS. Like
Yeah.
they don't care if I talk about it. Like the NDA is more for like the model and the drawings stuff. Like they have no problem. Like when we did our open house, I was running magwells and showing them off, and we checked before we did that, and they said that was fine. So as long as we didn't show people the drawings or anything,
Yeah.
any the
At that
models or
point, it's
anything like,
advertising for them.
yeah. And um, so yeah, we're doing the magwells, and then we're also doing some barrel nuts. So I got two parts for them that I'm running production on, and I've got another magwell that I could end up with middle of this year that they're working on, and I've got a barrel, another not a barrel part that I could be working on, and then another part. Some of these parts I'm not sure I can really talk about too much because they could be for upcoming products. So like
Oh,
that's the part I can't talk about. But I can talk about the ones that I do have, which are two. And so it was pretty cool because one week I got 750 magwells done and 500 barrel not barrel nuts, but threaded adapters. Um which is the other part I'm doing. It's not a barrel nut, it's a threaded adapter. And what it is it goes onto the end of a pistol. It allows you to put a suppressor on your pistol, I believe. So it's the adapter between the two. So those are the two main parts I run. And that adapter nut that we were doing would be the perfect one for a dual spindle Y-axis lathe. And so I got another part from them similar that if we get it and we get it in the quantities that they're saying we could get it in, that's when I'm going to get it. That's the part that would allow me to get a dual spindle Y-axis lathe to run production.
replacing your ST10 or
No, we'd still keep the ST10. So it would go. It would go against the back wall of the shop with a bar feeder, and then I would move the part I've been running on the ST10 15 ST15 over to that because
oh,
right now
it's not an ST10.
it's a 15. Yeah, because right now I can bar feed op one, and then I gotta manually load in op two every single time in the lathe, and then I got to take it over to the mill because they get some flats machined on them, and so that's another op. So it's three ops. But if I had a dual spindle Y-axis lathe, I could literally load in a bar and get a finished part and not have to touch it.
Nice. Yeah,
So
that would be the way.
yeah, so that's the right way to do it. Now we're still making money doing it the way we're doing it, but it's not nearly the amount of money we could be making it with the right
It's
machine.
painful money instead of easy money.
Yes, it's painful money, but it's money that I will take with a smile on my face because historically our lathe has been the least utilized
Mm-hmm.
machine in our shop, and with this job, it's keeping it pretty busy.
Nice.
So,
Yeah, that's what you
what?
needed.
Yeah. So like I'm more than happy to take that type of work, and we're getting more lathe work as time's going on. So um, I'm excited to see that machine pulling more of the weight than it has been historically. Because like if you're looking at spindle utilization, we've had that machine now. We're starting our third year with it, I believe, because we got it. We're starting our fourth year of business, and we got that machine after 1 year of business. So yeah, it's starting its third year, and spindle hours. It's I think the least spindle hours of any machine in the shop, and it's the oldest machine. So
Speaking of products, part of my plan for the next week or two is to do a bunch of product development stuff.
ooh, cool.
So I have like basically a minimal viable product that I'm working towards right now. I have everything I need except maybe stock. I need to check if I have scrap that's the right size or if I need to go buy some aluminum.
Mm-hmm.
But it'll be, like I said, that'll be like a minimal viable product, which will kind of be an accessory for the main product. I'll explain when I actually start developing it and if this is like I don't at this point it's an idea. Ideas are cheap.
Mm-hmm.
If I get something that if I start working on it and I'm moderately happy with it, I'll share it. But
Yeah. Yep.
I'll tell you after the podcast. The Discord already knows.
Let's see here. What else? I did some tape and glue method here a couple weeks
Ooh.
ago, but I actually made a fixture that used tape and glue.
Okay.
Uh, and
With like a
so,
locating pocket.
yeah, kind of locating slot.
Mm-hmm.
And so what it was is it was a plastic scraper. And so you can imagine kind of a blade, and they were all different lengths, but they had the same interface on the back side to hold them.
Okay. Yeah.
And there was it was a family of parts. And I'd done these parts in the past on the Tormach. However, the way I did them in last time involved a lot of setups, and I remember using the fixture the fixture I'd used last time. Basically, grabbed that plastic part by um, the common feature, and then would machine the rest of it that's hanging out, and it kind of bent up, and so the longer scrapers that were way out there, it had a lot of chatter, and it was kind
Okay.
of a
Yeah.
pain. And so I basically used the same fixture idea, but instead of grabbing onto that feature on the back, I used that feature to locate it, and then I used the whole bottom of the scraper as a tape surface to tape and super glue.
Mm-hmm. Nice.
And
What
so
plastic?
DP was it
HDPE.
HDPE? Yeah,
I know I've
and
machined some of that. It's better than UHMW.
it's better
Not
than
as good as
UHM.
Delrin.
It's like halfway between UHMW and Delrin.
Yeah.
It like machines. It's more rigid than UHMW, but it's stringy like UHMW.
Yeah.
And so I was really happy with how those turned out, because I remember last time they're plastic parts, and so like most of the features were plus or minus 10 or 15. But with this new tape and glue method, I got it to where I would I could do op 1 and op 2, and then the op 3 was in the fixture. And so I would do op 1 and 2 while I had the super glue fixture drying, and then I'd pop it out, bring it over, run it, pop it off the part. I'd take the next part that I'd done 1 and 2 on, slap it in there, and then start machining op 1 and 2 while op 3 was drying in the glue. And so like I had like a system that was going pretty consistent. And so that gave me enough time for the glue to dry to be able to use the fixture. And I dialed it in to where the parts are coming off within a thou of each other, like
Nice.
with the thickness of the glue and everything.
Yep.
And the finishes were so much nicer. And it's funny because I had the inverse problem on these, because as they got smaller, I had less glue area versus the other method with it when I was bolting it through. As they got smaller, it got more rigid. With these, it got less rigid. So it was like the
Yeah.
opposite problem.
And stuff doesn't like to stick to HDPE. So like your tape wouldn't be super secure.
Oh, my tape was super secure. Like
Oh, okay. Never mind.
it was not the problem. Like I got so good with the tape and the glue method that like I had to pry these things off, and they were on they were on there really hard.
Nice.
So I was super happy. So, but yeah, that was one of those where that method ended up working out the best. And then I also got to use the flow, like because these blades had like a lot of curves on them to like for how they were being used. Anyways, I was able to use the deburr method with the ball end mill,
Okay.
which I didn't do last time as well. So that took care of the stringy corners
Yeah.
on everything. Oh, and today I was actually machining some. I should have taken some photos. They're super cool. Some guillotine blades for a company, for like for like a company that makes like uh food.
Okay.
And so it was blades for cutting the product, and we had the blanks water jet cut, and then we had to machine the bevel to make them into a knife edge. And so I was joking with Weston that was our practice for whenever we make a knife as a product.
Yeah.
And so, but like we were machining like a knife edge into these sheet metal blades, and it was coming out so good. I was so happy with the fixture we developed for that one.
I hate jobs where they have a intentionally sharp edge.
Yeah. Well,
Yeah, I hate that.
yeah.
Because then it's like, how do you deburr it? Because it's supposed to be sharp. And did you ever see the cheese grater job?
Mm-mm.
Did I ever show you this was the one that put me behind on the big job.
No. Yeah, I didn't see that one.
So imagine like a cap that would go on the top of a piece of PVC pipe,
Mm-hmm.
where it's got like a half dome to it. Imagine that, but it has a radial pattern of little knives sticking up in slots.
Mm-hmm.
And the file name was like cheese grater. I don't think it was actually being used for cheese, but it was like a rotary cheese grater is the best way I can describe it. And it was 440 or 420 stainless. It was about 20 thou thick on all dimensions,
Mm-hmm.
and each of those little knives were at their own orientation.
Oh
Um,
man.
Also, it looked rotationally symmetric, but it was not.
Ooh, that's not fun.
So and I had to make like 3 or 4 of those or something like that, and those things were a nightmare.
Mm.
Um, I Man, I was going to tell you how I made them, but I literally don't remember right now. I had some sort of 3D printed jig to set up my orientations, which, oh, that's right. So I 3D, did I machine it? Oh my gosh, this was only like 4 weeks ago and I have very little recollection. So basically, I needed a 5-axis, but I didn't have a 5-axis. So I either 3D printed or machined an arbor, because I legitimately don't remember, that had the different angles on it,
Mhm.
like rotationally. And then fortunately, the axial angle was consistent. So I machined a pair of soft jaws that had a pentagon at like an angle. And then I was able to index my little, it ended up being a super glue arbor, my super glue arbor around and cut all of those little slots in there.
Oh man.
And it took a long time. I think my dollars per hour ended up being pretty good on that job, but it took me a long time and it put me behind.
Yeah. Once you get a taste of 5-axis, it'll change your world.
Yep, I definitely want to go there. But okay, so I mentioned that one of my plans for the next couple weeks here is to focus on to focus on products.
Mm-hmm.
I ordered a new 3D printer finally. I've been
Oh,
talking about this for like 7 months.
what'd you get?
I got a Bamboo P1S.
Nice.
So
You'll
I
be happy
got
with it.
with the AMS and like all the upgrades you needed to print, like carbon fiber and stuff.
Mm-hmm.
And I ordered a whole bunch of filament.
Yeah.
But the major driving force behind that was to do some of this product development stuff. And then also
Mm-hmm.
the other thing I'm going to do is automation stuff.
Oh yeah. Mm-hmm.
So I was playing around the other day with a 3D printed spindle gripper.
Mm-hmm.
And I'm like 85% confident that I can make it work, or at least make it kind of work. And so I've told myself I will allow myself 2 days to play around with automating this big job using that 3D printed gripper.
Mm-hmm.
And if it doesn't work, I'll just make a big pallet. But if it does work, then I'll run it automated with the spindle gripper.
Do you have a pneumatic? You have a couple pneumatic vices, or
I have the Aroa bases.
but that's not going to work for. So how many vices do you have that can go into them?
So this actually goes into what I was about to ask you about. So I have like 10 vices right now, some
Mm-hmm.
of which are for soft jaw, some of which are for like the grippy ones, the
Mm-hmm.
normal vices, the Op1 vices. What I was thinking about doing though is I have enough hardware to make at least 20 pallets, or 20 Aroa pallets. I was thinking, what if I made a big flat pallet and put some like Mighty Bite pit bulls on one side, and then had a bunch of spots where I could put a rail. So like every quarter inch or whatever, I would be able to put a one of those grippy rails. I was trying
Mm-hmm.
to look at. There's some guy on Instagram who makes them. It's
Talon
like
grips?
Anderson. What?
Are you talking about Talon grips?
Same idea, but there's some guy who makes like these rails, like 4
Okay.
fixtures, or you can put on a vise. It's like Anderson MFG or Anson MFG.
Mm-hmm.
I was looking for him here and I couldn't find him. So I'll give you a shout out next time if I can find your account. Oh, look, Anderson Manufacturing Inc. So he makes these cool little grippy rails, and I was thinking I could basically make a little vise with like a piece of material, a pit bowl, and one of those rails. And I could probably do those for like $20 each or something. Or I could just spend the money and get more of the price has gone up on them. So now they're $80 import vices. What do you think?
What's wrong with getting a pneumatic vise and
I
then
could
just
do
use,
that as well.
because I think the pneumatic vise is going to be the easiest method, personally. But the other method would give you more flexibility to do multiple ops, um, and let them run.
So
And
I 100% agree that for this type of job and for this specific job, the pneumatic vice is the right way to do it.
mm-hmm,
The thing is for future stuff, like my long-term goal is more around flexibility than producing a bunch of the same part,
mm-hmm. But isn't almost
which
every part going to start in a block form for op one? So one pneumatic vise would allow you to do all the op ones, and then you would still need another solution for two or three or whatever other ups you do.
you would need to set up the pneumatic vice for each individual part.
Yeah,
You couldn't, well, unless you got the lights out robo wrench thing, which is pretty slick and again probably the right way to go.
yeah, but are you wanting to run a high mix of parts in one automation solution?
Yes, that is my goal.
Okay.
I I was I while I was waiting for my students to show up that never did, I started editing my looking ahead to 2025 video that I recorded in like January 2nd and still haven't published yet.
Mm-hmm.
And this video explains my plan. But yes, I want to automate high mix onesie twosies. That is my goal. And my plan was to have basically a pallet pool and a robot and individually load the different Aroa pallets. Like that's everything I've been working for. We're working towards this entire year.
Okay.
An Aroa pallet pool. That's why I got the Aroa bases. And I'll need to build out my, vice collection, obviously.
So you already have how many vices currently?
Like 10-ish.
10ish. Then I would just start with that. Start with those 10 vices and see if you can get something to work before you invest time in a palette into a
Yes.
solution that you're not that you you got to validate the simplest thing first, which would be a spindle gripper to pick up one of those vices and stick it in the Aroa base. Start
Yes.
there, and if you get that system working, then we can come back. If you're doing
Yeah.
high mix, you're gonna want to do a bunch of small pallets anyways at some point. Like that's just gonna be a given. But you might learn some stuff along the way. Like, for example, you know they used to be Flux Work Holding. Are they still Flux Work Holding?
There's still flux. Yeah.
Okay, yeah, Flux Work Holding. They have that aluminum uh vise that's like all made out of a single block of aluminum that like can
Uh-huh.
tilt in. Like I could see something like that if you came up with a program where you could just make those types of vices that are just compatible with your spindle gripper and then using your regular vices for op 1. So do op 1 for those and then do like an aluminum vice like that for op 2 or 3 or whatever.
That makes a lot of sense. I was just planning on using the soft jaw versions of the Chinese vices, but you're not wrong. I could do something like that. Like a one-time use kind of disposable vice.
Yeah, and if you can make it and you can automate the production of those blocks, you just have to have the material on hand and then you could automate running those bases out of material, if we can come up with the right program for it. And then so like if your machine's not running and you start running low of those and you just keep a bar of whatever material that is on hand, and then you can run a whole bunch of them whenever the machine's not doing it something else.
Okay. Well, I think you just backed up what my current plan is. Yes. So I'm going to play with automation for a couple days. If I can get it to work, then I'll invest in some more vices and use it for this job. If I can't, I'll just build a big pallet. But yeah, my logic was the lights out robo wrench. By my math, I can get approximately 40 vices for the cost of that one robo wrench thing. or
Mm-hmm.
they have a cheaper version, which would have been about 16 vices worth. The
Gotcha.
difference being the Robo Wrench has infinite travel, and the cheaper one only has like 50 thou travel.
Gotcha.
So, but yeah, my current plan is to take my 6-inch vise is already off my table. Just put one Aroa pallet or one base on like the far left side of the table, and then I can fill the rest of the table with a grid of vices.
Mm-hmm.
And then it can just pick it up, plop it into the pneumatic base. The
Aroa.
pneumatic base will grab onto it. The lifter can lift off. When it's done, I'll probably have to have a second gripper come in, grab the finished part, and then go park it back in its slot.
Mm-hmm.
And as part of that, I have been working on new probing macros for Tormach.
Oh, really?
Yeah, they don't officially know that I'm working on these. Of course, Norman has been helping me, but I am making them feature complete with Fusion, because right
Mm-hmm.
now the basically everything you can do in the free version of or the non-manufacturing extension works, but
Mm-hmm.
I'm making them feature complete with the manufacturing extension, so you can generate inspection reports and stuff from that. And so I'll be able to do some automated checking. Obviously, you can't trust like completely the inspection report that the machine generates,
Mm-hmm.
because if there's any kinematic error in the machine, it will be equal in both the part and the inspection, or the tool and the probing.
Mm-hmm.
But as a nice sanity check, it will work well. So it'll be able to like check to see if, I don't know, something moved, whatever, if the part moved in the vise, or if the tool broke or whatever. And it'll give me a nice inspection report. And if I look at that and one of the parts is like a 1/4 inch off, I can go, oh, maybe I should go pull that part and check. But so I should have that up and running. Really, it probably will just take me about another hour to fix it or to finish it up. And then I'll
Multiply
send that
that
off to
by
Tormach so that,
4.
yeah, no
Time,
kidding.
like you got, what is that, like anytime you think it's going to take an hour or whatever, you multiply it by pi, the rule of pi or
Yeah.
whatever.
I will say the Tormach macros are so much better than the Renishaw macros,
Oh, that's
at
good.
least in readability. I don't know if you've ever tried to edit a Renishaw macro, but they are a mess.
Yeah, they're like referencing like 100 different sub programs, always bouncing
Yeah,
around.
they're a nightmare. Like I I understand why they wrote them that way, and they wrote them that way for flexibility, but it makes it completely impossible to follow the logic.
Yeah.
Whereas the Tormach macros, they have comments. They're
Mm-hmm.
well labeled. Tormach macros can use named parameters. So instead of it being like, parameter number 1024, and you just have to know what 1024 is, it'll say like probing position and probing result.
Mm-hmm.
And yeah, so I think Norman wrote those. Well done, Norman. You guys have murdered Renishaw and how clean your macros are. I am uncleaning them by adding things like spitting out the inspection report and the ability to use them to just measure and not set the work coordinate system
Mm-hmm.
and stuff like that. But
Do you have the Fusion extensions?
they come and go. It depends on if I'm working for next gen.
Oh, okay.
So if I'm going to go to a customer, they give it to me for a month,
Gotcha.
and
You
then
just
it
got to make sure once a
expires.
month you go to a customer.
I've had it for, I would say, at least 50% of the time since I've started doing work for next gen,
Mm-hmm.
which I should just buy that thing or convince them to give me a year.
Yeah.
But
How do you like it? The extensions, like, have you played with it much?
I would say without a 5-axis, the usefulness for me is right on the borderline. There's some
Yeah.
stuff that I would really like deburr and steep and shallow and the better probing stuff, but I'm not willing to pay $1,600 a year for it right now. But
Mm-hmm.
I'm really close to willing.
Yeah.
For 5-axis stuff, mandatory right away. Like when I'm doing work for, like I went to the engine company a couple weeks
Mm-hmm.
ago, like with them, it was like absolutely mandatory. No way we're not using that.
Yep.
But,
Yep.
and actually same with even the company I went to before them, the 3D printing company.
Mm-hmm.
For 3-axis stuff, I'm going to build. So I'll make sure that the macros are feature complete for the manufacturing extension, but I'm also going to build workarounds so that like if you want to use like just the measure without setting the work coordinate system, which you can't do in Fusion without the manufacturing extension, I'm
Mm-hmm.
just going to make it so that you can add a manual NC or maybe a post option.
Yeah.
So I'm gonna find ways that people with Tormachs can bypass the manufacturing extension. But
Yeah. The problem is you won't be able to probably the doing it that way. You'll either only be able to probe to measure or probe to set. Like you'll probably have to it'll probably be a checkbox because like if you want to intermix, find a like if you have a program and you want to find the material, then you want to machine it, then you want to probe it afterwards to inspect it. That would be the hard part, I would think.
you just add a manual NC.
Could
So
be.
it'd be Tormach has global parameters that are, well, there's a bunch of different kinds, some that are saved, some that are not saved, but they have ones that are saved until you start a new program. Or no, they're, yeah, so they're saved until you start a new program.
Gotcha.
And so I would say, and one of those parameters would be, change work coordinate system. And if you're doing probing where you want to set the work coordinate system, you would manual NC change work coordinate system equals true. And when you
Gotcha.
don't, you just do a manual NC change work coordinate system equals false.
Gotcha. What about oh shoot. I was just gonna ask you something and I forgot it. Oh, does I don't remember using this in Path Pilot or with my Tormach days. Program restart. Does it read the whole program or does it just start on the line?
Yes, it reads the program. Which, fun fact, there's actually a bug that I have found through some trial and error in that where it tries to read through the probing macro
Mm-hmm.
and it changes your active work coordinate system, like because it's replaying the macro and the macro goes, hey, I just
Oh.
probed something, and it probes it as your current location.
Ooh.
Scrap some parts that way too.
Oh, that's fun.
But
Can you turn that on and
Tormach is
off?
aware. What?
Can you turn off program restart? Like have it start on a line without reading everything in front of it?
I don't think so.
Okay. Because like that's a setting in the Haas where I can turn on program reset or not,
Yeah.
and you can watch it go through the whole program up to where you were, which for really long programs takes a long time.
Does
Like it's
mine do
not
that?
fast, but
I don't
huh?
know if mine does that. I wonder if mine does that.
Because
If it's something you have.
it'll replay the whole thing. Like you'll see the Renishaw probing macros come up, and it'll read through them. It won't set your another origin, but it'll just
That's good.
what it's doing is it's reading through and it's finding all the GM
Yeah.
all the and that way when it gets to where it was, all the machine is in the state it needs to be in for whatever line you're starting on. And so like
Yeah.
you can safely restart. Like if you're starting at the top of like a say you e-stopped right before an adaptive toolpath and you go to that header at the adaptive toolpath, technically everything you need to get the machine in the right configuration is usually Fusion will output all of that stuff at the beginning, and so you don't need to run program restart. You could just start on that line, and it'll automatically add in all the right codes that it needs because it's all in the header. But if you're starting in the middle of like a 5-axis program, then you need to do the restart because it'll reorient and get everything in the right position and all that fun stuff.
Do you know what I had big success with on this project that I haven't had big success with before?
What?
It's the both ways adaptive.
I've never really played with that.
Normally, normally it does not make a cycle time difference. It will normally, it'll normally either make your cycle longer because it does when it's conventional cutting, it slows it down, or it just won't make a difference at all. Maybe it cuts off a couple seconds. But on these parts, it cut off about 2 minutes.
Ooh,
And
wow.
I think it was because just the way the parts were designed, it wasn't like, normally adapters are kind of a loop, 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 where it's almost a circular motion. The way
Mm-hmm.
these were set up, it would be like it would go around, it would do a Z up, across, back down, loop, across, over, back down, loop. And
Yeah.
by instead of going over the island, going back and forth around the island, it cut off a lot of cycle time.
Makes
So
sense.
that was something I hadn't played with much before.
How are the rapids on the new machine?
I believe they're 1,500 inches a minute. Now, I may be confused by
Well,
it also being called a 1,500, but they
no,
feel fast.
I
Z
think
is
they're
half the speed, but
I think they're 1,200 inches a
are
minute.
they 12?
Yeah,
The,
but
the number in
sorry,
my mind is 1,500, but I think they incepted me.
I didn't mean rapids because I knew that I think it's 600, 1,200, 1,200. What
That
I should
sounds
have
right.
said is it's accelerations. Um,
I think that's something I need to tweak. Norman gave me a smoothing code that I've just been blindly using, but I think it slows down the accelerations a little too much.
okay,
So
because
I need to play with that more.
because one thing I noticed about the UMC versus the VF is that on these magwells, when we first got it all up and running, I thought the UMC would technically be faster because the rapids were faster for the for the B and C axis.
Mm-hmm.
They were 3 times as fast as what they are on the trunnion that we have on the VF. But when we posted the code, the VF was running the code in like 32, 33 minutes. And the first time we posted the code and ran it on the UMC, it was 52 minutes,
Wow.
over 20 minutes longer to run the same program from the VF to the UMC.
Well, didn't you say you had some issues with your spindle brake codes?
Yes. So there was two problems that we ended up diagnosing, which I wouldn't have thought of. One of them makes sense just watching it. The other one was driving me up a wall, and I reached out to my local Haas apps guy, and he was confused about it, and he reached out to the factory, and we got our answer. So the first thing is on the HRT 210 that we have on our VF, um, disengaging and re-engaging the brakes are almost unnoticeable in time.
Mm-hmm.
They're really quick. They do add time, but not much. And but on the UMC, it takes about 1.5 to 2 seconds per axis to engage and disengage the brakes. And one thing that Fusion does when you're running a 5 axis program, I don't know why it does this. It's annoying as crap. It's something I can probably fix in the post.
Yeah, it's a
Um,
post issue, not a fusion issue.
yeah, it's a post issue probably more than anything else. But anytime you do a tool change and it's going to run on the 5 axis, it'll put the M code to unlock both axes, and they're in separate lines. So it'll unlock the B axis, unlock the C axis. Then it'll command the rotary to move to the right position, even if it's already in that position. So say you wanted to be at B0, C0. It was already at B0, C0. It'll unlock both axes, command the thing to stay in place and not move, and then relock both axes on
For a
every tool
tool change,
change.
it locks them?
Yeah, and it'll relock them. And so basically every tool change is extended by what would it be like? So if it's 8 seconds per tool change, and it would also do it in other random locations. So like even if you didn't do a tool change, but like sometimes for some of the tool paths, and I don't know how to determine when to do it or not. Like if I went from a 3D adaptive to a 2D contour, it would do it as well. It would pause, unlock both axes, even if it's not moving, tell it to go to the same position it's already in, and then relock both axes. And so taking out all of those, it was M10 through M13 codes, taking them all out of the program, and then going back and manually adding the ones that it needed, which for reference, you can tell it to lock, and then it'll stay locked until you tell it to unlock. And then when you unlock it, it'll stay unlocked until you tell it to lock. And when you command a movement, you don't need to tell the axes to unlock or lock. The machine just does it. It can't move the axes without unlocking them.
Yeah.
So, but if you're we basically told it to any tool that was a 1/4 inch and under and was not roughing but only finishing, we could turn off the brakes for any of those tools. And so like for the last 2/3 of the program, the thing just stays unlocked the whole time. We never relocked the axes. And that took the program from 52 minutes. It took like 8 minutes out of the program. And so that was about half of the time that we were slowed down. And I couldn't figure out why we were still not as fast. And so that's when I reached out to our apps guy, and we were using G187P3 in the program. And so that's a smoothing setting in Haas. You have P1, 2, and 3. And 1 is for like roughing, 2 is their medium or what they're by default set to. And then 3 is like if you're trying to go for high accuracy. And so in Fusion, I just set that little flag to automatic, where Fusion will decide based
Mm-hmm.
on my tolerance settings which mode to put it in. And apparently, and our apps guy didn't know this, but P3 on the UMC, they have the accelerations reduced significantly further
Mm.
than on their VFs, and there was some issue they were getting, and so I basically changed all my P3s to a P2 because I didn't really need that as high accuracy as it was asking it to do, and that got it down to be within a minute, less than a minute difference between the VF and the UMC,
Okay.
between those two problems. And so anyone who's using a UMC and you want to take out a lot of time in your program, if you're having those issues, the brakes and G187P3, if you can figure out when to use those, when to not use those, it makes a major difference. I mean, in a program that's 34 minutes right now on the UMC, it basically doubled the time with those two settings.
Nice.
So, or halved it when you did it properly. So,
Well, speaking of doing things properly, we have Patreons.
woohoo!
Those Patreons are awesome and we appreciate them. I said things. We appreciate them. They do things, or they get access to things such as our totally definitely weekly Q&A, in addition to a actually shockingly active Discord server
Yes.
and early access to our episodes. Also, it helps support the podcast. Uh, we have some new members this month. I totally don't remember the last people we read off, but at least the people who joined in February, we have Ian B and Tyler Smith. And then if I can figure out how to do the filters, because I still haven't updated my spreadsheet. There we go. Our $10 a month and above Patreon. Oh, I just undid my filters. Come back, filters. Our $10 a month Patreons include Jacob M, Josh H, Chris Z, Dylan P, Freaky Climber, Prescott O, Alexander B, Scott at Design the Everything, Jamie Peacock with JSpec Engineering, Chris Zyke from Zyke Precision, EJ at Nocturnal Welding, Chris at Thoughtbomb Design, and as ever, Jake Brownson. So thank you guys. We appreciate you. We are probably going to bring in someone to do some podcast social media management for us finally, and that is all thanks to our Patreon members. If we do end up doing that, that will solve problems like our sometimes weekly Q&As. They'll be able to manage uploading video and Spotify, posting the Spotify thingy, which I know I'm particularly bad at. It'll just kind of streamline all of our social media and some of the management behind the podcast. So we'll let you know next week if that works out. But that is the plan. And that is all thank you to our Patreon. So that'll take a lot of work off of me. And I wasn't really doing the work. So it'll make everything better for you guys. Oh, I haven't done this plug for a long time. We are both on YouTube on the Audacity Micro channel, but also on Spotify or any podcast player. So if you're listening on YouTube, you can go check us out on your podcast player of choice. And if you are on your podcast player of choice, you can come check us out on YouTube.
Mm-hmm.
We also sometimes do live streams to our Discord.
Mm-hmm.
We didn't do it this time because, I don't know, I was tired.
Yeah. Sometimes it's nice to do them, but sometimes it can also be distracting. So it's a double-edged sword because I like having the back and forth with the community, but I feel like we need to do it like every other episode or
Yeah.
like once a month or something. I don't know.
Or do like a weekly stream just with the Patreons.
Yeah. Yeah.
Like jump in for a half an hour at a time or something?
Yeah, I would be down for that.
Now, would you consider live streaming straight to YouTube? I've done so. Originally, we actually started the Discord streams as a test for that.
Mm-hmm.
And then also, I've done some live streams on YouTube myself lately. Actually, I've done a lot of those. I've done more of those than videos because they don't require editing.
I mean, I wouldn't be opposed to it. I guess as long as there was like a goal or it was a little bit more structured in some way, I think that would help. Or maybe if it was not structured, where it's like instead of us trying to do what we do on the podcast, where we go over what happened during the week, I feel like it'd be too distracting. We just go with the flow of whatever the life people are saying and interacting with them. Because I have a hard time like going through my week and not getting pulled off on 1,000
Yeah.
different tangents and then trying to get back on track. And it's just like if I don't have a track to go down, it's much better.
We could do that like once a month or something as well.
Yeah.
I don't know. It's something to think about and to play with.
Yeah. But I wouldn't be opposed to it. Yeah, that's it.
We had a 5-second silence. It's time to hit the button.
All right, guys. It has been a long time, and we're both sorry for that. But we have been super busy, so it hasn't been from lack of desire. But anyways, thanks for hanging out with us. And I haven't done an outro in so long. I don't know what to do on these. But anyways, thanks for hanging out.
This is about par for the course.
Yeah, about par for the course. This has been Harrison with Precision Ingenuity signing out with AJ from Audacity Micro, and we'll catch up with you guys later.
Everyone who listens to us on a podcast app, I'm really sorry that I'm really bad about posting those.